everyone. Today let's go over another precursor to the famous number one, twosum. This one is called twosum 4 and the input is a binary search tree. So I solved this about half a year ago, so let's review it again. So let's read the statement. You're given the root of a binary search tree. So first of all, the root looks like an array, but it's not. It's a tree node object similar to the linked list that has three attributes: the value, the left, and the right. And now they give you this information. It's very important that this is a binary search tree. That means the left values are always going to be less than the node, and the right values are always going to be greater than the node. So in this case, 3 is going to be less than 5, 6 is going to be bigger than 5, 2 is going to be less than 3, and 4 is going to be bigger than 3, and 7 is going to be bigger than 6. So you're given an integer called k, and you want to return a boolean indicating whether you have any two elements that are not the same that sum up to k, and false otherwise. So the first question you might have is, okay, how do we deal with this input as an array, as a linked list, or as a tree? And the easiest way to do that, there are two different ways that I like to use to get all the nodes of a binary tree. You can either do level order traversal, or you can do depth first search pre-order. So I'm going to do depth first search pre-order, or I'm actually do level order because it's simpler for this video. So let's call this Q. So we're defining a deck, a doubly ended Q, where you can pop left and append to the end. So it allows you to, for example, pop from the front and from the back. From the back and the front. So and O of one time. So now we're going to append the root, which is actually tree node object. And while this deck is not empty, that means we still have more levels or more nodes to process. So let's call this level. This is just a list to hold if the nodes are not none, what their integer values are. So let's iterate over our queue, which is going to have the nodes that we currently need to process for the very next level, which is one down from the one we're seeing. And let's pop from the front. So if you pop from the front, then this is a node. This is not a value, right? It's a tree node object. So you have to make sure it's not none before you append the value, because none type objects do not have a value attribute. And then let's append the left child. And let's also append the right child. And at the end, if they're actually the list has at least one element in it, then we're going to define a final result array and append the level inside of it, which is going to hold all the nodes in the current level. If you take a look here, so 5, 3, 6, 2, 4, 7, each level left to right, pretty simple. And now we can flatten this into a 1D list, which is going to be easier, because what we're actually going to do is, instead of appending this list, which is going to give you a list of lists, let's just say result.extend level. So that's just going to combine two lists in Python. You have this and you have this, then that's just going to make this into one. So extend is essentially the same as plus. It's pretty handy. And if you'll see, then if we print result now, just have one nice flattened one-dimensional list, which is good. And now we can simply iterate over our list, right? Or we can use binary search, whatever way you'd like. But my goal of this channel is to make the solutions as intuitive as possible. So let's do a double loop. I+1 link the result, because we don't want to start at the same element or have duplicates, because if two elements, you can't use the same element twice to say it sums up to k. So you can't use 5 and 5 to sum up to k. So if result I plus result of j, because they're going to be different, is equal to k, then return true. If you get to the end and you never find anything, return false. So as you can see, it passes all test cases. There's another binary search way of doing this. I'm not going to show this in this video, because my goal is to make Leetcode solutions as simple and straightforward as possible. And yeah, so hope you enjoyed this video and hope that my goal was achieved there. So please stay tuned for more and consider subscribing. So see you in the next video.